as we know now that the Macaulay duration is not really a risk measure. This is because the price sensitivity here is not computed with respect to any risk factor, but with respect to the yield of its own bond. A real risk measure for a bond should be the price sensitivity with respect to a risk factor. Key rates are risk factors. As we have seen in a previous video, the key rates determine the price of the bond, and hence the change of any of the key rates will surely change the price of the bond. Hence, for a bond investor, those key rates are the risk factors. Since we have learned how to use the numerical method to compute the Macaulay duration in a previous video, we shall use the same technology to compute all the key rate durations here. From its name, we know that a key rate duration is the price sensitivity with respect to a key rate change. From the US Treasury Department website, we know that the key rates used here in our 10-year bond are 1, 2, 3, 5, 7, 10-year rates. So let's highlight them. Hence, we need to perturb or shock these key rates one at a time, as we did in a previous video for the Macaulay duration. In the Macaulay case, we only need to copy-paste once. Here, we need to repeat that for 6 key rates. Hence, using copy-paste is very inefficient. It is best that we write a simple macro program to do that. We use Alt F11 to bring out a macro page. We insert a module. In this module, we can start writing a macro program. To build a function in Excel, we use the command function. And then we need to give this function a name, just any arbitrary name. So let's call this bond price. And in this function, we have to have some inputs. And we need to name these inputs as well. So give them some arbitrary names. So we need all the cash flows. So let's just call this cash flow. And we also need market interest rates. Let's call this MK rate. And then we also need all the times. So let's call this time. And in addition to these major inputs, we also need to tell this function which key rate that we want it to compute, to perturb, to compute. So let's just call this key. So you can see that there's an additional line inserted called the end function. So now the function is ready to go. Now we need to loop through all the times. So we just, for the loop in Excel macro, it's called for. It's a for loop. So I've got 1 to 10. Now for loop will end with next. So I type in next and go back and insert a line. And I also indent it for easy viewing. So what I need to do is that if this I happens to be the same as my key rate, then, so if then is the command, and I indent it again for easy viewing, and I make my discount factor, let's call that disc fact, is equal to 1 divided by 1 plus the key rate. So we have market rate, market rate. Now this is the ith market rate, so I put it in here. So if it is the key rate that I need to shock, then I need to shock it by a small tiny amount. Let's just say 0.0001 as an example. And then to the power of time with index I. So now that I'm done with if it's key rate, otherwise, which means if it is not the key rate I want to shock or perturb, I will just do the discount factor as the regular one without perturbation. So I just copy that down and I just delete this. So I'm done with this and I need to end the command. So just call end if. So if else and if is the logic that we use Excel macro. Now, once this is done, so I need to compute the product of each item. So product is equal to cash flow of I, and then times the discount factor. Now I need to do the sum product, remember, in Excel. So the way to do that is I keep accumulating this product. So I'm going to call this AQ. It's accumulating, so it's equal to itself, and then adding the new result to it, which is prod. And then I'm done. And now my bound price is set to be my result, which is AQ. So this final command has to be the function name equals to my result, and that returns the result to the function. Now that I'm done with my macro programming, I'm coming back here to actually use it. Let's pick a cell and type in the function. So it equals bound price, which is the function name. The bound price has 3 major inputs. The first one is all the cash flows. And I want to anchor these cash flows so that when I copy, they don't change. So I use F4 to anchor this. And then the second input will be my market rates. Again, F4 to anchor. And then the last one will be my times. So anchor, fix that. Now for the very first one, I don't have any key rate to change. So I just put down 0. So my key is equal to 0. Now you can see that I have a price that's equal to the market price, as it should. Now I can copy this down. Now when I copied it down, I need to make a change because I want my key rate to enter. So this is my first key rate, which is equal to 1, and that's A4. So when I change my index from 0 to 1, I can now copy. Okay, now I have all the new prices. These prices are based upon perturbed key rates. Now I proceed to calculate key rate duration. So the key rate duration will be the price change. So the price change will be over here. A higher price, which is the original price, minus the lower price, which is perturbed the price. I need to anchor the original price such that it won't change when I copy. And then divided by the yield change. And the yield change, remember in the macro program, we use 0.000001. So I can copy this. Now I can calculate the duration, the second step, which is taking the price sensitivity divided by the price of the bond, and then times 1 plus the yield. So the price of the bond, I have to anchor. So use F4 for that. Copy, paste, 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 paste. So here are all my key rate durations. So for the very first one is 0.024 year. So to have some sense about what it is, so that's multiplied by 365 days a year. So it's roughly about 9 days. And the very last one is almost 8 years. So that's all the key rate duration. Lastly, I would like to talk about the effective duration. When the entire yield curve moves, the price impact that we see is called the effective duration. So not only the key rates move, the non-key rates will also have to move. As a result, we basically just copy all from key rates to non-key rates. And then we have all the duration numbers for the effective duration. We just sum them all up. As you can see, this is 8.91 years, which is very close to the Macaulay duration number. Now, this effective duration result is not very accurate because the linear interpolation we use to find non-key rates, it's not a very good methodology. There's a better methodology called triangular rule, which we will discuss in another opportunity. If we use triangular rule, then we will reach a much better estimate for the effective duration. Here we use, again, linear interpolation, which is not a very good methodology. Nevertheless, we still have some approximation for the effective duration. Again, this effective duration turns out to be very close to the Macaulay duration. As a result, even though Macaulay duration is not really a risk measure, people still use it simply because empirically, the Macaulay duration result is very similar to effective duration result. See you in the next video.